All right, let's get fired up for this deep dive. We're going to be tackling reusable heat shields today.
Ooh, hot topic.
Yeah, and we've got stacks of research here, academic papers, some engineering reports, even dipped into Wikipedia a bit.
A little bit of everything.
Exactly, the whole shebang. So by the time we're done here, you'll be, well, basically an expert.
Ready to dazzle everyone at the next dinner party.
Exactly.
Yeah.
All right, so first things first. What exactly are we talking about when we say heat shield?
Well, in the simplest terms, it's that barrier protecting a spacecraft when it comes screaming back into Earth's atmosphere.
Right, keeps it from burning up like a meteor.
Pretty much, yeah. It's all about managing that insane amount of heat generated by friction.
It's got to be tough.
Oh, incredibly tough. It's a complex system, really, designed to withstand both extreme temperatures and deep pressures. Now, we used to think of heat shields as basically one-time use.
Yeah, burn up on reentry or break apart.
Right, gone. But now, the real excitement is all about reusability.
Makes sense. Why build a new one every single time, right?
Exactly. It's about sustainability, efficiency, bringing those costs down,
Which, of course, brings us to SpaceX and their audacious Starship program. They're all in on reusable heat shields, aren't they?
Big time. Starship's heat shield is a masterpiece, really. It's made up of thousands of these hexagonal tiles.
Wait, hold on. Thousands of tiles. Why not just like one big shield? Seems simpler.
Well, there's a method to the madness. Those hexagonal tiles, they allow for flexibility, expansion, contraction. Think of it like chainmail armor, Can take a beating and still hold its shape.
Oh, okay, that's clever.
Plus, if a few tiles get damaged, you just swap them out. The whole shield stays intact.
So what are these tiles made of anyway? They must be pretty special to handle that kind of heat.
Oh, they are. Primarily silica, which has, incredible heat resistance. We're talking temperatures hotter than molten lava.
Whoa, okay, my mind is officially blown. And how are these tiles even attached to the spacecraft? Wouldn't they melt and fuse together under all that heat?
Nope. They're attached with these flexible pins. Allows for movement, expansion, contraction. There are even gaps between the tiles, to give them room to breathe.
Wow. Talk about attention to detail.
Yeah, every little bit matters. And speaking of details, you'll remember that SpaceX actually made some pretty big design changes after their initial testing.
Right, after those early flights.
Yeah, they saw some wear and tear on those tiles. So they added a secondary layer, an ablative layer underneath the tiles.
Ablative. Refresh my memory on what that is.
Think of it as a sacrificial layer, something that chars and erodes away, taking the heat with it. Like that crust on a loaf of bread, protecting the soft inside.
Oh, so it's like double protection. The ablative layer takes the initial hit, and the silica tiles stay safe underneath.
You got it. Now, even with all these advances, reusable heat shields like the one on Starship, they're really designed for travel within our solar system.
Makes sense. Our little neighborhood, relatively speaking. But what about going interstellar? What about those trips to other star systems?
Now that's where things get really interesting. Interstellar travel throws a whole new set of challenges at us. Challenges that our current tech might not be quite ready for.
Interstellar, so we're talking, what, light years away?
Oh yeah, vast distances. And to make those trips in any reasonable time frame, we'd need to travel at speeds that are, frankly, mind-boggling.
Good chunk of the speed of light, I imagine.
Exactly. 20%, maybe even faster. And at those speeds, suddenly, it's not just about heat from atmospheric reentry.
Right, everything changes out there in the interstellar medium.
You got it. Even something as small as a dust particle at those speeds, it becomes a serious hazard.
Like a tiny grain of sand.
Yeah, think of it like a microscopic bullet. And when it hits a spacecraft at, say, 20% the speed of light, the energy released is enormous.
Ouch, that's gotta hurt.
More than hurt. It could be catastrophic. And of course, there's the heat generated by those impacts, too.
Okay, so we're talking a shield that doesn't just handle heat, but also, constant bombardment.
Exactly. We need materials that are, almost impossibly strong, lightweight, and able to absorb insane amounts of energy. Some researchers are looking at things like beryllium, boron, the exotic stuff.
Sounds like we're at the cutting edge of material science here.
Oh, absolutely. But it's not just about the material itself. The shape of the shield matters, too.
Like aerodynamics, right?
You got it. A streamlined design, minimizing the number of impacts. That's key. Less stress on the shield overall.
So basically, a nice, sleek, pointed shape, like a spaceship from those old sci-fi movies.
Huh. Well, maybe not that far off. But there's another factor that comes into play with interstellar travel. Self-healing.
Self-healing.
Yeah.
The shield repairs itself.
Exactly. Out there in the vastness of space, We can't exactly pull over for repairs, can we?
Right, no pit stops on the way to Alpha Centauri.
So we need a shield that can, in a sense, regenerate. Close up those microcracks, fix any damage in real time. Think nanotech, maybe some kind of futuristic active material.
So we're talking like a living shield almost.
In a way, yeah, it's still very much in the realm of theory, but the possibilities are, well, mind-blowing. And it's interesting to think about all this talk of interstellar travel, but what about the applications of reusable heat shield technology here on good old Earth?
Right, back down to Earth. What kind of impact could this have on, I don't know, everyday life?
Oh, the potential is huge. Think about firefighters, for example. Imagine suits with built-in reusable heat shields, allowing them to move safely through the most intense fires.
Wow, that would be incredible.
Right. Or industrial settings, places where workers are exposed to extreme heat. Reusable heat shields could revolutionize safety protocols.
It seems like the possibilities are endless. And who knows, maybe the tech we develop here on Earth for those everyday applications could then feed back into space exploration, helping us push even further.
Absolutely. It's a two-way street. Innovation in one area often sparks breakthroughs in another. The future of reusable heat shields, well, it's bright, both here on Earth and out there in the cosmos.
So as we wrap up this deep dive into reusable heat shields, let's take a moment to recap what we've learned. We started with the basics: what a heat shield is, why it's important, and how it works.
Then we jumped into the amazing advancements happening right now with SpaceX and their Starship program leading the charge.
Their innovative design, with those thousands of silica tiles and that ablative layer, it's a testament to human ingenuity, really.
Oh, for sure. And of course, we couldn't shy away from the challenges either.
We tackled the mind-boggling complexities of interstellar travel, where even tiny dust particles become, well, weapons at those incredible speeds.
It's really fascinating to think about what it would take to protect a spacecraft on such a journey. Self-healing materials, streamlined shapes, a deep understanding of particle physics, it's all on the table.
And as we talked about, it's not just about spaceships and distant stars. Reusable heat shield technology has the potential to impact our lives here on Earth in some very real and important ways.
That's right. From improving safety for firefighters to revolutionizing work in extreme environments, the benefits are clear.
So, to our listeners, I think the takeaway here is that reusable heat shields, they're not just a technological marvel. They're a symbol of our ambition, of our relentless desire to push the boundaries of what's possible.
Beautifully said. Whether it's venturing to other planets or protecting those who protect us here on Earth, this technology is shaping a brighter future.
And who knows, maybe someone listening to this right now will be inspired to contribute to this field. Maybe you'll be the one to develop the next generation of materials or the next groundbreaking design that takes us to the stars. Until then, keep exploring, keep learning, and keep diving deep. It really is amazing stuff. And, it makes you wonder, what's next? What's the next big leap for reusable heat shield technology?
Well, that's the million-dollar question, isn't it? I think we'll see those silica tiles on Starship continue to evolve, become even more robust, more efficient.
Yeah, got to handle those multiple trips to Mars, right?
Exactly. But beyond that, well, who knows? Maybe we'll see completely new materials come into play. Materials we haven't even dreamed of yet.
Like those self-healing materials we talked about. That would be game-changing, especially for those long-duration missions, interstellar travel, all that.
Absolutely. And maybe, just maybe, we'll start to crack the code on truly bio-inspired designs. Shields that can adapt, heal, even grow, just like living organisms.
Okay, now that is some next-level stuff. But,
yeah.
Hey, it's fun to speculate, right?
Oh, absolutely. And, sometimes those wild ideas, they're the ones that lead to the biggest breakthroughs. So to everyone listening, keep those imaginations fired up.
Couldn't agree more. Well, I think that about wraps it up for our deep dive into reusable heat shields. It's been a blast, as always.
It really has, and hopefully everyone listening has a better understanding of this amazing technology, its challenges, its potential, the whole 9 yards.
So until next time, keep those brains buzzing. And don't be afraid to ask the big questions. Who knows, you might just be the one to come up with the next big innovation.